Let me now explain the practical organization of the course. So the course is organized around lessons. So we will have 12 lessons in the course, and we will have around 2 lessons per week. So it's 6 weeks or a little bit more than 6 weeks. With each lesson there will be exercises. So there will be the usual conceptual exercises on the EDX platform, multiple choice and other forms of exercises. But since this is a programming course, there will also be programming exercises, and these will run on another platform called Pythia, which will be accessed through EDX. And finally, for the programming homework, you will be able to install the Mozart programming system, which is an open source system on almost all existing platforms. So let me just briefly overview then the whole organization in terms of software. So in the EDX platform, then we'll support the online course, and it links to Pythia. This platform also will have the documentation, so text and slides to complement the videos. The second part is the Pythia interactive platform for submitting programming exercises and for correcting exercises. So it gives you feedback on your programming errors so you can resubmit a corrected version. So Pythia is running on a cloud, an Amazon cloud, together with its version of Mozart, so it's scalable with any number of students in the course. And the final system then is the Mozart, which implements the Oz language, and which you can install by going on the Mozart website, which I give here, www.mozartoz.org. And in order to do the homework exercises and in order to prepare the Pythia submissions, you will need to install Mozart locally. So let me give a brief overview of the lesson plan of the 12 lessons. So the first lessons will be on functional programming and also introduce the basic ideas of kernel language, the concepts and basic concepts of grammar and language and so on. So there will be on recursion, invariant programming, also list data structure, then higher order programming. So higher order, which is a very important concept that will be used throughout the course. Also records, which are an important structure and concept that we'll use throughout the course. And then we'll end the functional part with a discussion of trees and a very nice example and a practice midterm. Then we will go into the next theme. So in the first part, we already have introduced some semantic concepts, but we will bring it all together here in the lecture number 6, where we will talk about correctness and semantics, and we will present the abstract machine, which gives the semantics of the whole system. And then we will go on to the third theme, which is data abstraction. We will present explicit state. We will present the different ways of doing data abstraction. Then we will show how object-oriented programming can be seen as an elaboration of ideas of data abstraction. And finally, we will terminate talking about Java, which is a very popular object-oriented language, multiple inheritance, and the concept of exceptions. Then we will go into the fourth theme, which is deterministic data flow concurrency. We'll talk in general about concurrent programming. We'll give many nice examples of agent programs and how the programming works and also the semantics. And we will end up with a very nice multi-agent example of digital logic simulation. And in the final lesson, we will take a step back, look over all the material we have seen, again, put it into the context of programming as an overall field, and also give links and pointers to further your execution. And just to finish, I would say the course textbook is the book Concepts, Techniques, and Models of Computer Programming, published by MIT Press, and MIT Press has graciously accepted to make available part of this book for the course.